Hello, welcome back. As I promised earlier, for the rest of the video on this physics session, we're solving 20 past utme questions on this 11 most repeated topic in physics utme. In the last video, we were able to touch measurements and units and some parts of motion. So we are going to continue where we stopped on the last video. If you are ready, I'm also ready. So let's jump right in. Question number 4. From the diagram below, the region of zero acceleration is taken from Jam Pass question 2014. So they're asking us the region of zero acceleration, right? So this is a velocity time graph, that is velocity plotted against time. For me, you can see that from m to n, you have acceleration, right? We have a change in velocity, right? But from point n to s, we have a constant velocity. Recall that acceleration is equal to change in velocity over change in time, right? If that is the case, from point n to s, we have a constant velocity, so the velocity doesn't change. So we have the change in velocity should be 0, right? By change in time, and this will give us 0, right? So at point n to s, we don't have a change in velocity, and this will give us a 0 acceleration. So for me, I can see that the correct option for me is option B, right? So the point of 0 acceleration is point n to s, where we have constant velocity, because acceleration is the change in velocity or the change in time, right? What's the next question on the most repeated topics? In the diagram below, a rod 50 cm long of uniform cross section is suspended horizontally on a fulcrum F by the action of two forces, right? What is the weight of the rod? This is taken from Jam Pass question 2007. Okay, this is on the topic equilibrium of forces. So you can see that we are being asked what is the weight of the rod. Okay, so from equilibrium of forces, you know that the weight of the rod at the center for a uniform solid like this, right? So if that is the case, if we redraw this diagram, we now have something like this. Okay, this is 0.5, this is 15, this should be 25, and this is 45 and 50, right? So this is 0 point. So at this point is this mass 200 Newton. This is the point of the fulcrum. Then at this point, which is the midpoint of this uniform solid, we have the weight of the rod. The weight of the rod acts at the center. Okay, so at this point 45, we have a 40 Newton, right? So our job is here is to resolve these forces. So we now use the principles of moment, right? So if this is the fulcrum, from 15 to 5, this is from this distance to this distance is 10. 25 to 15, this is still 10. Or 45 to 15, this now give us 30, right? So we are taking the moment at this point of the fulcrum. If that is the case, 200 multiply by the distance between this point where it's being hung to the point where we are taking the moment, which is 10, right? That is the anti-clockwise moment. Then the clockwise moment will give us the weight of this rod, which is acting at the center of its gravity, right? Also by distance between this point then to the point of the fulcrum, which is 10, it now give us the weight multiplied by 10, right? Plus this 40 Newton, then the distance from this 40 Newton where it's being hung to this point is 30, right? So 40 times 30. Okay, 200 times 10 will give us 2000, right? Is equal to 10 multiplied by the weight, which is 10W, plus 40 times 30 will give us 1200. So if you collect like terms, then 2000 minus 1200 will give us 800, is equal to 10, then the weight of the rod. Then make it double the size of formula, divide by 10, divide by 10, right? You can see that the weight is equal to 80 Newton. So you can see that the correct option is option D. So the key factor here is just to know that for a uniform rod like this, the center of gravity is at its center, and at that particular point of center of gravity, that is where the weight of the rod tends to act, right? So just mark at points. You can see that this rod is 50 cm long, so the center is the 25 cm mark, right? So at that 25 cm mark is where the weight of the rod tends to act. Okay. So the next question: distance between two successive crests of a wave is 15 cm, and the velocity 300 meters per second. Calculate the frequency. This is taken from JAM 2014. So we already know that if this is a wave, right, we have this. Okay, the distance from the successive crest is what we call the wavelength, lambda. Very, very important. So if I can see that I'll give you the wavelength straight to the point, right? That lambda is equal to 15 cm, which have to convert to meter, very important, which is 0.15 meter. We are given the velocity as 300 meter per second, right? We come from that relation that velocity is equal to the frequency multiplied by the wavelength. So the frequency is equal to the velocity divided by the wavelength, which is the 300 divided by 0.15, and this will give us 2000 Hz. Converting 2000 Hz to the standard form 1, 2, 3, that is 2.0 times 10 to the power 3 Hz. Okay, consider the correct option is option C, straight to the point. Your knowledge of this relation, very, very important, and your knowledge of the interpretation of a wave is very, very important. That the distance between the successive crest is the wavelength. The distance also from the successive trough is also the wavelength. And distance from this point to this point where it completes a circle is also the wavelength. Very, very important. So in these three questions that we saw, we're able to touch some parts of motion, the equilibrium of forces, and some parts of wave, right? To get more simplified explanation of past question on the most important various topic in physics UTME and others ones, then you need to get the simplified UTME video series where experts will give step-by-step explanation to over 600 plus past questions for each subject. These questions and their solutions are arranged topic by topic according to the UTME syllabus. This is one study material that you must get if you wish to score as high as possible in your UTME exam. So call or WhatsApp the number on the screen now to get yours.